after you're retrieving your data in Google Cloud using Google Cloud BigQuery, we can now start cleaning the data. So I added the cleaning and analysis, or rather, it's more of cleaning the Python file for the cleaning here. So you can just download it and save it to your directory. So I'm just going to download it and save it to my directory where I have my CSV file from the previous activity or data retrieval activity. So I'm just going to save it. Okay, so going there. So I'm going to open the cleaning.analysis.py. So you can open this one in your own say you can open this one in Notepad or even in here. So if you notice, this is we are using here Pandas and NumPy, although NumPy is not really being used here. So since it's in the gray, so it's really not being used. So I just added it more of a reflex. I usually tend to add all of the packages that I have in case I might need it. Anyway, so you have your CSV file. So from the previous activity, we had exported our query to a CSV file. So that's ph2020 at covid.csv. So we can actually run this one, or we can just do the console. Where's the console? Okay. So we can just run this one, or first, of course, we need to import pandas. So just run it in the console. So take note, this must be in the console. So we imported pandas. And then we are just going to read my CSV data. So we are just going to input here. So in this command, you are inputting your ph2020 COVID. This is the CSV file that we used a while ago. Now, first, let's look at the first few rows. Let's look at the headers of the rows. Okay, so we have here 5 rows and 7 columns. We can actually look it here. So 1, 2, 3, 4, 5, 6, 7. And then for the heads, we have basically initial 5 rows. So this is just the head. So initial, so rows 1, 0 to 4. Because Python counts starts from 0 anyway. So you have this one, and then we want to see columns with similar values. Do we have columns with repeating values? So this command prints the columns with a non-unique value, or the number of non-unique value is 1. So if you have a column with all values are the same, it will be printed here. So let's run it in the console. Okay, so here, okay, this one tells us country code is false, country name is true, cumulative confirmed, deceased, recovered, population. Okay, now the thing here is, if you look at the country code, it's not actually the country code, but it's actually the date. But the country name is all of the same, of course, all of them from the Philippines. So if you look at this one, country code, or rather, this is actually the date. So these have unique values. They are non-unique. But the country name is the same. So that's true. Cumulative confirmed, deceased, and recovered cases are all false because they have changing values here. So these three are changing. But this column here, the population in 2018, or as of 2018, is marked as true because it doesn't change. And then the case percent is false, of course, it's changing. So we have now 2 columns that have the same. So we can just remove these columns because they're very redundant. So let's just remove them. So just type on this command, actually copy paste. So drop the columns. So basically you have now your data frame. The empty columns, these are the dropped ones. Okay, so you can see here your data frame. So this is your data frame. So case percent, columns, cumulative confirm, so on and so forth. Now, the country name is no longer found because you have dropped it. Okay, now let's rename the header because as you can see, the country code is the header but is actually the date. So let's just rename them. And also, cumulative confirmed, deceased, and recovered have all the same. Actually, they have very long names. So I want to rename them. So let's rename first the column for your country code. So this one rename your column for country code and replaces it with the name date. And then run it. So you now have your new column name, or rather new header for your column, which gives the correct heading, which is the date. And then let's try to rename multiple columns this time. So this one, since we are going to change almost all of them, we are just going to, instead of individually doing that, an alternative way to rename columns is just make sure that you are familiar or you know the order of the columns as they appear, in case you might switch around the names of the column, and then you will get you will have a mistake. So the first one is the date, and then we have the country name is no longer there because we dropped this column, so we just get the confirmed, disease, recovered, and the percent cases. So this one has dropped already. Confirmed, disease, recovered. We dropped the population, but we have the case percent. So we just rename them. So I'm just going to copy this one. So you can rename your column any how you want. I just removed the cumulative part because it's too long. Okay, so I rename those column. And then let's see. So basically you have now those rename columns. So let's see. Confirm, date, deceased. Okay, so these are the new columns. We have percent cases. Okay, the next one. Let's see if there are any null or empty spaces. So this one checks for empty cells. So here you have false. This one are null value. So true, you have basically 0 or empty spaces. So the is null command gives you back the zeros and the empties. So we can just replace all possible empty spaces with a different or with NaN. So let's try to copy this one. So all zeros, all of the true here, values in the true here, will have a value of NaN. Okay. We don't define numpy. Okay, so here requires us, because it's NP. So we need to import numpy. I forgot to import numpy, so let's just import numpy as NP. Okay, and then paste it. Okay, so no error anymore. So anyway, this happens if you have a non-defined name. That means one of the possible reasons is that you have a typo error, of course, in the vessel name, or if it's a command, you didn't have the np package. Usually, this is just some people import numpy as num. I just had it imported as np because this is one of most common people usually import numpy as np. Okay, so anyway, this one replaces the null with NaN. And then let's fill them, remove the NaN because these are non-numerical, fill them with 0. So why do we need to first fill them with none and then fill the none with 0? Because this command basically replaces all of the empty cells with NaN. And then all of the NaN now we can be further replaced with 0. So we must first fill it up with NaN and then fill it up with 0 after. Okay, and then remove these empty rows. So if you have rows that are empty, this one removes it. So df drop your 0 cells. So you now have 550 rows times 5 columns. And then save it. So let's try to save it to a new CSV file so that we can see what happens. So saving it. So we now have our new cleaned, where is cleaned? Cleaning analysis CSV file. So page 2020 COVID cleaned. Where is that file? Here is the 2020 COVID clean. So let's open this. Okay. So as you can see, we no longer have the dropped columns, the Philippines, and of course the population, just the percent cases. And then the date started not on January 1, but on January 23, where you have the first non-zero row. And then all of the empty spaces are replaced with numbers. Okay, so it's that all of them are either removed or replaced. So this is now, and then we now have the last data from June 19. So unlike this one from before, you have empty spaces here. Basically, the whole new almost 1 month full of basically no information whatsoever. And then you have empty spaces here. So they remove the empty spaces. So the last one is from the complete set from June 19. Okay, so that is what your BigQuery, or rather cleaning, data cleaning does. So this is your cleaned data. So this is based on your date. So you can actually apply Matplotlib here to visualize your data. I will no longer upload a video for Matplotlib because that is already covered in your Coursera course. So here ends the tutorial demo for data retrieval and cleaning of your the data. Okay, so thank you for cleaning it for tuning up or tuning in again. So anyway, I had designed this Python file, by the way. If you notice the triple quotations, so that each line will is designed to actually be run individually, because you want to see what happens for every step of the day. For example, here, if it's working, instead of just running all of them in a single run, you might encounter problems, and it will be difficult to actually find each problem 9 by 9. So anyway, that ends our tutorial and demo. So I hope you will be able to do your activity 2.2 peacefully this time.